us go to the next example. So, in the next example, what is happening is that we are still having reciprocation circuits, but now we want to have a regenerative configuration. What is regenerative configuration? See, previously you will recall that in all your cases, when you were trying to move the cylinder one end, suppose you want to extend the rod, so you push in fluid into the cap end and the fluid comes out at the rod end. So, you connect, basically you connect the cap end to the pump and you connect the rod end to the tank. Now, here what we are saying is that we want to recirculate some of the fluid which is coming out of the rod end into the cap end. So, how that is possible? So, that is exactly what is being shown here. So, you see, again identify components first. So, you have this is say A, pump, this is B, relief valve, this is C, directional valve, and this is D, a cylinder. Now, see that we have drawn the cylinder rod a bit thick just to ensure that the rod area is not negligible to the cylinder piston area. This is the piston area, capital A, and this is the rod area, small a, suppose. So, what is happening is that now the two side areas are different, right. Also look at this particular directional valve, which is two position, and it's kind of it's detented in the sense that, so when you what happens when both the solenoids are off. So, in both the solenoids are off, then it stays in the position corresponding to the last operation of the solenoid. So, if last the solenoid A was on, then it will, even if you take A off, it is going to remain at the left position. So, that is due to a mechanical arrangement. So, that is detention. Okay. So, now what is happening here is look at this, that suppose the pump flow here is V, right. So, so what is happening is that this part, what is the flow? This part, the flow is if this is V, see the ratio of the flow into this, suppose it moves by a distance x, then the volume filled is A into x, and the volume which is expelled is A minus A into x. So, if this is V1 and if this is V2, this coming out, then V1 V2 by V1 is equal to A minus A by A is equal to 1 minus A by A is equal to 1 minus 1 by K, 1 minus 1 by K is equal to K minus 1 by K. So, this is V2 by V1. And V1 by V2 is equal to K by K minus 1. Okay. So, now what is now? So, again V is equal to V1 minus V2 is equal to V2 yes, is equal to V1, V is V1 minus V2, so it is V1 minus V1 equal to K by K minus 1 into V2, so it is K by K minus 1 minus 1 into V2. That is equal to what? That is equal to 1 by K minus 1 into V2. K minus K plus 1, so 1 by K minus 1 into V2. And so V2 is equal to K minus 1, let us write it at a different place. So we get two equations, we get V2 is equal to K minus 1 into V, and therefore V1 is equal to K into V. These are the two, let me encircle them in a different color, these are the final expressions. So these are the flows, you understand? Similarly, so you see that, so if typical case is, this is the case during extension stroke. So actually you see that though the flow rate is K into V, typically K is greater than 1, but the actually the fluid drawn is from the pump is small v, right. Now what happens in the retraction stroke? In the retraction stroke, so in the extension stroke it is going to go like this, it enters like this, and then again part goes this and part goes. This is the flow patterns in the extension stroke. What happens in the retraction stroke? In the retraction stroke, now you are in this position. So now this is the path, directly this is the path, there is no fluid addition or anything. So now what is happening is that if this is V, then this is V, and obviously because it directly goes into this, and what is going to be this? This is going to be naturally this will be so A into rather A minus A into V suppose it moves distance x. So if this is V, suppose the area is half, then this side it will be K into V. The distance moved in unit time is actually V by A minus A, if V volume is flowing, this is the distance traversed. So that into A will be the volume which will be expelled. So it is going to be A by A minus A into V, which is equal to A by A minus A by A is equal to 1 minus 1 by K is equal to K minus 1 by K. So A by A minus A is going to be K by K minus 1, yeah. So it is going to be K by K minus 1 into V. This is the rate at which the fluid will get expelled, okay. This will be the flow rate. So what are we achieving by doing this? Similarly, if you look at the pressure, then you will find that So, you see that suppose the one interesting thing that happens is that suppose A is equal to 0.5 of A, or rather A by A is equal to 2, right. So, then what happens is that you can see that the for example, with the same pump flow rate V, the distance travelled per unit time is going to be, if this is V, this is going to be the flow into this is going to be V, and in the previous case what was happening? In the previous case what was happening is that if we go to the previous case, how do we go to the previous case? Yep. We came little fast. Yeah. In the previous case, we were having so you can actually find out that we have to do it again. We can actually find out that the interesting point is that you can work it out. In fact, this can be a nice exercise, that there are two things that will happen. The first thing is that you will find that number 1, 2 points. Number 1 is that, say, let us say 2:1 area ratio. Then you will find that the extension and retraction speeds are same, but they are not going to be same for other area ratios. That must be remembered. Similarly, you will find that, so you see, we can find that at a smaller, if we directly connect it to tank, say in the case of the extension stroke, if we directly connected this to pump and that to tank, then we would have had a slower motion. With the same pump flow rate, we would have got a slower motion, which we are. So, the advantage of regeneration is that with the same flow rate rating pump, we are able to generate faster motion, but at the same time we will see that we will require higher pump pressure, right. So, what happens is that, I mean, basically for that is, when we will require higher pump pressure, if we want to drive a load which requires the same force to be driven, then in the regenerative circuit we need higher pressure. So, basically we are trading off pressure with flow, that is, we can use a lower flow rate pump to achieve a certain speed, but at the same time if you want to achieve a certain force, then we have to give higher pressure. So, this is the basic feature of this regenerative retraction circuit. So, moving on to the next one, this is a regenerative reciprocating circuit with changeover to conventional mode. So, what is happening here? Basically the same type, only thing that is happening here is that here you see, initially we have again pump, I am sorry, what is this happening here? Again you have pump, you have relief valve, you have 3 position direction valve with solenoids and hydraulic pilot, and so in the first case, in this position that is shown, flow is like this to the cap end, starts moving, goes this way, and this is wrong actually. You should draw it like this. So, comes freely and there is regeneration, right. So, initially there is regeneration. So, with the given pump flow rate, speed will be higher. Now, if at the end there is a higher force encountered which cannot be supported by the prime mover at that flow rate, then what is going to happen is that the pressure here will build up. Whenever this faces resistance, the pressure here builds up. when the pressure here will build up and this is opposite, so this is going to be connected like this. So now you see that it will be after the pressure builds up, it will connect like this and flow through this. So now across this there will be a full pressure and there is no regeneration. So therefore the speed will fall and therefore it will still be able to handle the pressure, right. Now so at the end, if there is a higher force requirement, it will change over by this valve from a regenerative circuit to a conventional reciprocating circuit. What will happen in the other position? In the other position it's very simple. In the other position it will be here. So then what will happen is that this will be the flow. So it will directly flow through this check valve straight and it will come back directly, it will actually come back here and it will get connected to tank. So that's a very conventional mode. So in this case it will there is no pressure requirement and it will come back. So on the only advantage is that since we have higher force requirement, so as long as the force requirement is manageable by the pump, we are going for a regenerative circuit having, so with the pump flow rate we are achieving a higher speed, but whenever the force requirement goes up, so we are immediately switching over to the system automatically switches over to a conventional circuit. Pressure is now full applied, so we can manage and the flow rate falls and with the flow rate we have a lower speed. So that is the advantage of this circuit. Next, we have a sequencing circuit. So in the sequencing circuit, what is happening is that here now in this example we have more than one cylinder. So far what we have been doing is that we have handled only one cylinder, but sometimes it happens that you need to operate multiple cylinders and for example, suppose you have a woodworking machine, right? You have a planing machine. So before you plane the machine, before you start moving the planing cutter, you have to hold the job. So the sequence is that first operate the holding cylinder, then start moving the planer. So the planer extends, then the planer retracts, then remove the clamp cylinder. So you see that we have every time we operate, we have to operate it in first clamp, then extension of planing cylinder, then retraction of planing cylinder, then unclamp. So this is a particular sequence of two cylinders which have to be operated. So now we will see how we can achieve this one, right. So here we are. So here is the circuit. So what are we going to do? Look at this circuit. So we have here we have two cylinders. One is J, another is H, right? And we have normal pump. This is the main valve, okay, which is being operated. Here is the relief valve D, and these are the three valves which actually cause the sequencing, right. So now what happens is that initially cylinder H extending, right. So it is in this position. Look at the position. Then what is the flow? Cylinder H extending means it flows through this check valve open direction, flows into cap end, goes out through this, flows through and returns. Here is tank. So this is the position, and so the cylinder H is extending, going up. This is the first phase of the cycle. After some time what will happen is that cylinder H will stop. It has to it comes across a mechanical stop. Now what happens? So the moment it comes to a mechanical stop here, this pressure will now build up, because there cannot be any further flow through this. Flow is stopped. So immediately this point rises to pump pressure. That will operate this valve, right? Cannot go through this, at this point. So it goes through this and starts pushing valve J. So flow goes like this, like this, like this. So cylinder J extends, right? All through this, remember that this pressure, there is a pressure on this. So this pressure is holding. This is pressed. Cylinder H is pressed up. So there is a, if you are using it for clamping, there is a clamping pressure. Next, cylinder J retracting. Next, what happens is now you have moved the solenoid. So you have moved the solenoid, and it is now, actually this is wrong. Actually this is wrong. This should be connected to this point, and this pump should be connected to this point. So now the pump flow is connected like this, goes through this, cylinder J retracts, flows out through this, free flow, check valve, and goes through this to pump tank. Cylinder J retracts, right? Next, last point. Last point. Now cylinder J has retracted fully. So now this pressure cannot. So now the pressure here builds up. So the pressure here builds up. So the pressure here also builds up, and this now pushes the cylinder down. But this time, note that it has to pass through this. So therefore, while the cylinder H is coming down, there is always a back pressure. This is not connected to tank because it's not passing through this, it's passing through the relief valve. So the cylinder H coming down is actually being, here the net force is actually being controlled. So it is coming down slowly. You know, sometimes when you have vertical coming down, etc., under weight, you want that the going up can be fast, but going down has to be at a low force. So this is what we have achieved by so we have achieved the sequencing. So these are some of the circuits, and what we have seen in this lesson, we have seen unloading circuits, system pressure selection circuits, various kinds of reciprocating circuits with rapid modes, reciprocating circuits with regeneration, reciprocating circuits with regeneration plus conventional, and finally we have seen sequencing circuits, which are basically reciprocating circuits with multiple cylinders. Okay. So that brings us to the end of the lesson. Points to ponder, many questions you can think of. For example, can you imagine what would happen if the check valve was not present in the first unloading circuit? There will be problem. How would you modify the system if you wanted to unload pump B instead of pump A in that first system? That's very simple. The circuit is very symmetric, so you will have to, whatever you did for pump A, you have to move for pump B. Why are lines connecting C to D and D to E marked in dashed lines? This is the second one, that is system pressure selection, because they are pilot lines. Sorry, I have already given an answer. You are supposed to think about it. One thing I wanted to mention is that in many cases you will find that I have said that some limit switch operates and that operates some solenoid. So how does that happen? So you have to have a scheme for that. Sometimes you can have a purely electrical scheme, sometimes you can have a simple, sometimes you can have a simple relay type scheme, or sometimes you can have a PLC based scheme. So various special arrangements are needed. So for example, I have given one. Can you briefly describe a scheme to automate the above system such that whenever in the intermediate pressure mode pressure setting is exceeded, the system would automatically switch to the low pressure mode. Previously it was being done manually as it is shown in there. So, you can devise some control mechanism by which it will sense the pressure and it will switch on. How does the solenoid get energized if the limit switch is made? Same question. Is the speed of the cylinder going to be equal during extension and retraction when you have a regenerative circuit? If not, then what decides the speeds? We have analyzed this. It is the area ratio, but how does it decide? That you figure out. Explain all parts of the symbol of the directional valve C, basically same except for something special. This is about the regenerative reciprocating circuit, only the directional valve has a detention, that was the only special thing. This is we have discussed regarding the issues regarding pressure and flow. So, that brings us to the end of the lesson 28. Thank you very much.